Hello and welcome to today's class. For today's class, we'll be considering a very important concept under the study of trigonometry called relationship between trigonometric functions, right? In our last class, we discussed about the introduction to trigonometry, right? So the very first class you need to watch is our first class, which I'll be dropping the link above you here. So try to check the link up here. You see a link there to our first class on trigonometry. So, and I said in the last class that I created a playlist for the study of this course. So to understand trigonometry very well, I did series of video for this course. So check out our playlist under our page under trigonometry. You see our video arranged accordingly, right? So this is our second class here under trigonometry. So let's try to understand the concept behind relationship between trigonometric function. First things first, my first task when it comes to this concept is to draw out a right angled triangle. So first things first here, my first task here is that let's say I have a right angle triangle. Let's say I have this man here, a right angle triangle. What we know before now is that a right angle triangle has four sides. So let's call this side here. Let's call this A, B, C, three sides per se. So this is one side, two, and three side. So from this concept now, let's say this place here, let's call this angle theta, right? We know that this one here is what? 90 degree, right? It's perpendicular, so it's 90 degree here, right? That's what we know generally. All right. If this one is 90 degree, this one is theta, what would this one be? What would this angle here be? Don't forget that from our basic knowledge of triangle, what we know is that the sum of angle in a triangle is equal to 180 degrees. That is to say, if I add up all the angles in a right angle triangle, it must give me 180 degree. So it means that I'm having 90 degree here. I'm left with what? 90 degree. So to get 180, I need 90 and 90. So this one here is 190 degree. This 90 degree now is left with what? With these two angles here. So now, if this one is theta, what will this angle here be? This angle here becomes 90 minus theta. Take note, please. This angle here becomes angle 90 minus theta. It means if I subtract 90 from this theta here, I will get this 90 that is left here. So which is somewhat what? 180 degree. All right, I understand this concept here. So let's try to derive the relationship between trigonometric functions ranging from sine, cosine, tangent, secant, cosecant, cotangent. Let's start with the derivation. All right, first things first, let's start with sine, please. Let's start with sine. All right, before we proceed, last class we discussed about the concept of SOHCAHTOA, right? In our last class, we discussed about the concept of SOHCAHTOA. So we're applying the concept of SOHCAHTOA here too, right? So let's try to derive the expression or perhaps the formula when it comes to relationship between trigonometric function. Let's start with sine. You know, we're having sine theta here. So let's say sine theta is equal to what? What's sine theta? That's what? Opposite of our what? Hypotenuse. So I'll have opposite all over hypotenuse. At this point here, what's my opposite? We said anywhere the angle, this angle is facing, is the opposite. So that's BC. So BC is my opposite. All over hypotenuse is the longest side, which is constant. That's AC. Sin theta, I'm considering theta here. So now at this point now, after getting this expression, considering angle C, please. At this point, I will not consider this angle C. This symbol is for expressing angle. So angle what? Angle C. This angle C here. If I consider angle C, if I consider this angle here, it means that this one here is my opposite. Don't forget, please. Anywhere the angle is facing is what? Opposite. Why this one becomes the adjacent if I'm considering angle C. So considering angle C now, what's BC? If I'm considering angle C, what's BC? BC is what? If I'm considering this angle, BC will be what? Will be adjacent, please. That becomes adjacent as my BC all over. What's AC? Considering this angle, what's AC? Hypotenuse. So hypotenuse. So this is equal to, observe that I'm having adjacent over hypotenuse. There's a kind of trig function, or perhaps trig ratio, that represents adjacent over hypotenuse. Look at it. Adjacent hypotenuse. That's what they cos. So this becomes cos of 90 minus theta. Why is it 90 minus theta? You know, I'm considering angle. This angle here, this theta, this angle here is this is the angle I'm considering. That's why I have cos the angle I'm considering, which is 90 minus theta. So now we are saying that the sine theta is equal to cos of what? The complement angle, which is 90 minus theta. This is the very first mathematical formula you need to note when it comes to relationship between trigonometric function, that the sine theta is equal to the cos of the complement, which is 90 minus theta. So this is the very first formula you need to note, which I've derived here. Sine theta is equal to what? Cos 90 minus theta. This is the first one here. The second one there is what? This is sine. This is the first one here. Let's consider number 2 there. Number 2, this is sine here. Let's consider cos theta. Cos theta is equal to, what do we know? That's adjacent all over hypotenuse. Hypotenuse. What's my adjacent? If I'm considering this angle theta, listen, no, I'm considering angle theta. What's my adjacent? This is my what? Sorry, AB is my adjacent. So I have AB as my adjacent all over. Hypotenuse is always constant. That's AC. I have AC. Please, at this point now, let's consider angle C. If I consider this angle C, what we know is that this one here becomes opposite. Angle is facing here. This becomes opposite. What is one adjacent? This hypotenuse constant. So if I'm considering angle C, what's my AB? AB becomes what? The opposite. So I'll have opposite all over. What's AC? AC, hypotenuse, always constant. This means that, look at this SOHCAHTOA. There's a kind of trig ratio that represents opposite of hypotenuse. Opposite over hypotenuse. That's what? Sine. So I'll be having sine. Which angle am I considering for this one? That's angle what? 90 minus theta. So this becomes the second formula, that cos of an angle is equal to the sine of the complement. So this is the second formula you need to note when it comes to the relationship between trigonometric function. Let us call the third one there. Let us call the third one, number 3. That's tan theta is equal to opposite all over adjacent, please. Adjacent. All right, at this point here, if I'm considering theta as my angle, what's my opposite? This is A, that's BC. I have BC all over. Adjacent is what? AB. I have AB. So considering angle C now, if I consider this angle C, we know that AB is now opposite. In that case, BC is now adjacent. AC, hypotenuse, always constant. What's BC? BC is what? The what? Adjacent. I'm considering this angle. So this angle here is opposite, here is adjacent. So BC is what? Adjacent all over. What's AB? AB is what? Opposite, please. Opposite. Now looking at my SOHCAHTOA concept, there's never something like AO. Observe, this is AH. This is OA. This is OH. There's never something like AO. So it means that adjacent or opposite represent what? The cot of what? 90 minus theta. So I'm saying that if you check our previous class, when we're deriving some concept, we said that cot is equal to what? Adjacent of our what? Hypotenuse, when we do some derivation. So what our first class to understand why this one is cot. So it means I'm saying that tan theta now is equal to the what? The cot of the complement angle, which is 90 minus theta. So note this number 3, or perhaps the third formula when it comes to calculating, or perhaps when it comes to relationship between trigonometry functions. Point here, what's your next task? All right, I've given you 3 formulas here, so I'm saying that note the following, please. Note the following. When it comes to relationship between trigonometric function, there are about 6 formulas there. I just derived 3 for you. This is the first one, second one, third one. I will add up 3 more. So we're saying that when it comes to relationship between trigonometric function, know the following, that sine theta is equal to cos of the complement angle. Number 2, cos theta is equal to sine of the complement angle, which I've said here. I've given you this one here. All right, proceeding. Number 3, I'm saying that tan theta is equal to what? So yes, cot of the complement angle. Now number 4. Now look at number 4, please. Sine, cos, tan. What's next? Secant. So sec theta is equal to cosec of the complement angle. Number 5, cosec theta is equal to sec of the complement angle, which is 90 minus theta. Number 6, final one, cot theta is equal to tan of the complement angle. Please, when it comes to relationship between trigonometric function, the major, what we need to know under this concept is what? All this is mathematical expression. So know this one. This problem, this formula here will help us in our study of trigonometry, right? So now let's now use this idea to solve some problem, and let's see how this is now making sense, right? Let's see how it's making sense. Welcome back. Let's try to solve this problem under the concept we have just learned now, under the concept of relationship between trigonometric function. Let's solve this problem here. The problem says find the value of theta in the following. So let's start with number 1 there. Find theta in the following. Number 1. Let's start with number 1. Solution. Number 1 there says that tan into theta plus 35 is equal to cot into 3 theta minus 5. So let's solve this one here. Let's find theta. How do we get theta here at this point? Please, when it comes to solving something of this nature, don't forget these people here. This formula will help you to solve that problem. So understand this man here well. All right, let's try to solve this problem here. All right, I'm saying this is tan. All these are the angle. So this tan. If I say tan theta, observe tan theta. This theta here is the angle. So this is tan the angle. This everything here is the angle, which is so tan. No, we are meant to be having tan theta. We're having tan everything here. So everything here is what the angle of tan. Cot, everything here is what the angle of this cot. So understand that one first. All right, let's solve this problem here. What do we know first? This tan theta can be expressed in another way. We recall that at this point, we say that tan of any angle is equal to what? The cot of the complement, which is 90 minus theta. Observe this formula, this one here. Observe this two, please. Observe. This one was from this place here. So I can record this, right? So from here now, anyone I see tan theta, I will replace it as what? Cot of 90 minus theta. So this means that I'm seeing tan. This tan now replace it with what? Cot of this complement angle. So we're having cot of what? 90 minus what's theta? Theta is what? The angle here of this tan, right? That's what? 90. That will be into theta plus 35. Observe what I'm doing, please. Square bracket, please. Use a square bracket. Alright, observe please. I said tan theta is equal to this. Anyone I see tan, replace that tan as cot, as you have seen here. Cot into 90, which is 90 minus, but this tan has an angle. What's the angle? Everything here is the angle for this tan. So this angle here replaces this one, which is what I have here. So it's now equal to, from here, is equal to the cot of what there? Of 3 theta minus 5. At this point here, let's get it right. In mathematics, listen, oh, if I have AB is equal to CDA, if I have a number or alphabet which are equal, like I'm having the same alphabet in the opposite side of an equal to, they can what? They can cancel out. So this is mathematically correct. So I'll let what B is equal to CD. This is correct, that if I have something, the same thing at the opposite sides, they can what? Cancel out. So it means that this cos can cancel out this cot here. So it means that I'll be left with what? 90 minus theta, minus tan theta is what? Minus theta plus minus plus will give minus 35 is equal to 3 theta minus 5. From here now, let's get theta, please. This is 90. This is minus 35. Then this one, if this plus minus 5 becomes with the plus 5 is equal to 3 theta. This one comes and becomes plus theta. If minus theta comes and becomes plus theta. From here I'll be having what's it called? 90, right, plus 5 is 25. So I'll be having 60. 60 here is equal to 4 theta. 3 theta plus theta will give 4 theta. So I'll be having this divided by 4, divided by 4. 4 here, 4 here. I'll have that theta is equal to 60 over 4 is 15. So the angle that I'm looking for here is what? Is 15 degrees. So the angle for this one here is 15, as you can see, as we have solved in front of you. Right, for this number 1 here, let me emphasize on something. For this number 1 here, I can choose to go this way and get my 15. I can also solve this one in another way, right? So let's say I have this same question again. I have the second way of solving this problem. This number 1 problem is that I have tan. Tan of what? This angle theta plus 35, right, is equal to cot into 3 theta minus 5. Observe this one. For this one here, I consider tan. I record tan. Let's consider cot in this case. Recall that cot theta is equal to tan of the complement angle. True or false? True. Observe this and this, please. Observe these two, please. Observe this and this, please. Observe these two. They are the same, please. Alright, this means that at this point here, anyone I see cot theta replaced as what? Tan 90 minus theta. So I'll have this tan here. Tan into theta plus 35, right, is equal to, anyone I see cot replace as what? Tan. I have tan of this angle 90 minus what's theta? Theta is everything here. That's what? Use a square bracket here. That's 3 theta minus 5. So I have this. Let's get this done, please. From here, what do we know? From here, what do we get now? We said that it's mathematically correct that this one here cancels out this one, right? So I'm having what? Theta plus 35 is equal to 90. This 90 here minus 3 theta. So I have minus 3 theta minus is plus 5. From here now, theta, from here, this theta here, minus 3 theta becomes plus 3 theta is equal to this 90 plus 5, right? If plus 35 comes because of the minus 35, this becomes 4 theta is equal to 60. So divided by 4, theta is equal to 15. Observe that irrespective of the way you solve it, you have what the same answer as you can see in front of you. Let's try to solve the second problem here, number 2, and let's see what we get. Alright, let's try to solve the second problem under this, right? And let's see what we get, please. Second problem says, if I have sine 5 theta to be equal to cos theta, we said either I consider sine using that idea, or I consider cos using this second idea. So either I consider each of them. So let's say we are considering cos, for instance. Recall that we said that cos theta is equal to sine of the complement angle, which is 90 minus theta. Anytime I say cos theta, it replaces everything here. So we're having sine 5 theta is equal to cos theta. What's cos theta? Everything here. That's what? Sine into 90 minus theta. Sine cancel out sine. That becomes 5 theta is equal to 90 minus theta. Let's get theta. This becomes 5 theta minus theta coming because of the plus theta is equal to 90. This becomes 6 theta is equal to 90. Divided by 6. I'll have that theta is equal to 15. So my answer here too becomes 15 using the concept of cos theta by solving this one. The second way around is what? Using what? The sine. I use cos in this case. I can still use sine. I'll have the same 15. So the second way of solving this number 2 problem is that if I have sine 5 theta to be equals to cos theta, what's the second way of solving this man? You know, for me, we say we recall that cos theta. Let's recall for sine. Recall that sine theta is equal to what? Cos of the complement angle, which is 90 minus theta. From here now, anyone I see sine, I'll replace as what? Cos. So this is sine, Abi, becomes cos of what? 90 minus, what's my theta here? Theta is now what? 5 theta. So that becomes 90 minus 5 theta. So I have this to be equal to what? Cos theta. Cos cancel out cos. This becomes 90 minus 5 theta to be equal to what? To be equal to, okay, theta, right? I will left theta, please. Theta. You know, I cancel cos and cos. So left it was this theta. This is theta here. So take this one here. I'll have 90 is equal to this theta. If minus 5 theta comes, it becomes plus 5 theta. From here, I'll have 90 is equal to theta plus 5 theta becomes 6 theta. Something of, sorry, 90. Look at this, and look at this, and look at this. Something of this nature. Alright, look at this and look at this. They are the same thing. You can see that, right? So it's more of saying 6 divided by 9. 19 divided by 6 again. So it becomes divided by 6 by 6. Theta is equal to 9 divided by 6 is what? Is 15. So the angle here is 15 degrees. As this is how to solve problems of this nature. See you in our next class. We'll be discussing about fundamental functional identity, right? Fundamental trigonometric identity. Yes, fundamental trigonometric identity. What we're discussing about, we're looking at the concept of 1 plus tan square theta is equal to sec square theta. We're looking at 1 plus cot square theta is equal to cosec square theta. We're looking at cos square theta plus sin square theta is equal to 1. All these concepts in our next class we'll be discussing about fundamental of trigonometry identity. So see you in our next class. Do well to invite your friends to our class, to our YouTube page. Tell them to subscribe to our channel, and also do well to watch our video before you download, right? Try to watch them online for a little bit, for a while, before you download the video. It helps us in our progress of our YouTube channel. So see you in our next class.